Welcome to my first OpenRocket tutorial. Okay, the purpose of these tutorials are to start with the OpenRocket for people new to the hobby, and the very first tutorials will be very basic. You get people in there, get them to use the software with the least fuss and muss as possible. Following on tutorials, we'll go into greater depths as to what we're going, what it's capable of. But we're going to try to keep that to a minimum for now. I'm going to try to keep each one of these to around 10 minutes apiece so you don't get bored to tears while you're watching these things. And let's move right on in. When you download OpenRocket, it is a Java file, and if it doesn't create one of these shortcuts, you can create it yourself. If you look at the properties on it, it's basically all it's doing is running the jar file for OpenRocket right there. Okay, so if it doesn't create one, you can create it, and that way makes it easy for you to start up. Or you can just go to the jar file and click on it if you want. But I find this to be the easiest way. So I'm going to double click on my OpenRocket, and you can see it starts with 1503, which is the current version of OpenRocket. A new version will be coming up soon. Now let me get out of the way. This is the main screen for OpenRocket, and let me get out of the way so you can see the whole thing. And right here is your parts list that you're going to be using. This right here. This side here is all your component selection, and here is your build area. Okay, the bottom part here. So to get started, you can do any of these three things that are highlighted. Usually the easiest to get started with is the nose cone. So we're going to select the nose cone. You select the nose cone, it brings one up. It calls it a nose cone, and you can call it anything you want, but by default it's called nose cone. Just type it in if you want to change it. Here's the shape. There's all kinds of shapes, from elliptical to whatever. And there's some of these have features that you can change. Let's see, here's conical. Okay, it's just like here, if you change the shape parameter, it changes the way it looks. Okay, and this gives it the length and the base diameter, wall thickness if it's plastic, or it could be solid. Okay, and this one's saying it's cardboard. It's important that throughout this process you choose the correct materials, because that has to do with the weight of the materials. And if OpenRocket doesn't have the correct weight for the objects, it's not going to calculate the simulations correctly. So make sure you set these correctly. Okay, and the component finish paint is all I ever use, but you can do whatever you want. Now, in any of these things where you'll see select preset, if you pull it down, you can go from the database, and these are a bunch of manufacturers and parts that they carry. All right, so we're going to keep things easy by selecting all Estes stuff. And we're going to select, and next is 20B, okay? And it's giving you a bunch of parameters and descriptions and stuff. You'll notice there's a checkbox here. You don't need it checked, but you do need it highlighted. And you'll get that. That is the BNC 20B nose cone right there. And you notice it still made it balsa wood. It said it's got a regular paint, gave you the length and the height and wall thickness. Okay, and it's telling you whether it was filled or not. It's balsa wood, so it was filled. Okay, so there's no reason for us to change this, so we're going to stick with that. All right. Now, once you have the nose cone, you'll notice here you got these two symbols. This is a CG symbol, and this is a CP symbol. Okay, and by putting those together, they calculate stability. Over here on the right side, you'll see stability. All right, for a stable rocket, you want a positive number. If it's a negative number, the rocket is unstable and not pliable. So we're looking for something positive. Obviously, a nose cone by itself is not stable. All right, once we got the nose cone here, then we want to add a body tube to it. And because you selected a BT20 nose cone, it knows it needs to put a BT20 tube on there. But, it doesn't have any specifics on it. And we wanted to choose specifically Estes parts. So we're going to go here from the database and we're going to say, we're going to look up Estes and we're going to look up BT20. Where is it? BT20. Here we go. Right here. Hit OK. Now, you notice it made it really long because that tube is 18 inches long. And it made it 18 inches long. Well, we don't need 18 inches. We're going to stick with something like, 10 inches. That sounds reasonable. Then we're going to hit close. And the materials were right because it was Estes. It knew what it was. Okay, so now we got a model that's a little over. You look at this; it's about a little over 11 inches. It's about right. Okay, so now we got a tube in. We notice our stability is now negative 5.7. Not stable. Not stable at all. So we want this red to be behind it, toward the bottom of it, on the other side of the CG. Okay, so now here's something you need to know. In order to, so everything else is gray here. In order to put anything else on here, you have to select what you want to put these other items on. So we obviously want to put it on the body tube. So we selected the body tube. You notice it highlighted it. And now it's going to let's put all this other stuff on it. Well, we're going to put, we're going to start with some fins. Here's your sample fin, and this is something that, this is a standard trapezoidal fin. You can select the number of fins, the rotation, that means how far they're rotated around, their cant. This one, you really don't want to do unless you're an experienced guy. But you notice that if we can it tilted it a little bit. And that's for people who want them to spin on their way up. Personally, I don't want mine to spin. So we're going to do that. Okay. Root cord is the part that's against the rocket body. So you can make that longer or shorter. Your tip cord is a spot away from the body. So we can make that longer or shorter. Okay, and we can make the sweep length, which is this, longer or shorter. Okay, and we can do something like that back there, and then with sweep angle, we can see right now it says it's 50 inches, 50 degrees. I'm sorry, and we could make it shorter. Or like that. Okay, and it's because the sweep length why it won't let us have any more. So if we make the sweep length bigger, we can now increase the angle. Okay, so if you play these two against each other, you can get all kinds of things. Let's see. Sweep length. See? And that's more like the typical one right there. But we're not going to choose these right now. Oh, by the way, you can say it's based from the bottom of the part, and you can offset this if you want to. See, move back or up, doesn't matter. This cross section is square, and that's the leading edge and back edge. It's telling you want it square, you want it rounded. Okay, and this is the thickness of the fin. Typically 1/8 is the least I use. I've made them thicker, but fins I always make are balsa or fiberglass. So It's telling you what are you going to make your fins out of. We're going to make it out of, let's see here, they got to have balsa around here somewhere. Do. Oh, here it is, balsa. And the reason why you want to select the material is so it gets the weight correct. Because now you notice the stability is 1.49. So that means this rocket is stable. So we can move this back to 0. And we're 2.13. So this rocket is stable just as it is. Okay. So we're done with that. But we don't really want to just do trapezoidal fins. I just want to show you the other one. So we're going to highlight it and hit delete. They're gone, and our stability went away again. I'm going to choose the body tube. I can either do it this way or click it here. And you can see we can do an elliptical, which we can change the shape of that with the same thing that we did before. I don't personally like ellipticals, but you can do that. And here's the one I typically use the most. Whoop. Hit the body tube and the freeform. Now, it looks a lot like the trapezoidal here. The difference is you can go to the shape, and now I can change the shape. So by clicking on one of these little square notches here, I can make this as long as I want or as short as I want. Let's see, we'll go here, and then we'll take this and we'll move it down so we have a little bit of a rake to this. Okay, go on. And now I'm going to move this over here. And see, that's kind of nice. But now I want to add another point. So if I click anywhere on the line, click on it, and I can do that. All right, now you notice here's all your X and Y coordinates of every one of these points. And it says right here, you can click and drag any one of them, or you can control click and remove a point if you wanted to. We're more concerned if our stability is 0.67. That's good. We're going to leave it right there. Okay, so I'm going to close it. And there you go with a nice set of fins. Well, the other things we might want to add is click the body tube again. We'll need a engine block to keep the engine from going. You notice it says that it's going to start from the bottom. That's fine. And we know that all 18 millimeter engines are 2 3/4, so we're going to make this it's 2.5. It's minus because it's going up the rocket. Since we're starting at the back end, we're moving back up the side of the rocket. So we're going to do that. And see, put it up there, moved it up. And you notice the stability is still there. We're fine. Okay, so that's fine. You know, it's going to be cardboard. That's typically the way. You can go into the Estes thing and choose an engine block if you want to. In this case, it's not going to make any difference because they're all basically the same for a standard engine. Okay, so we did that. Let's see. We also would like to have a launch slug. So we highlighted the body tube. We got a launch slug. Launch slugs are typically, you either want to have two pieces, one above and below the center of gravity, and usually it's helpful if they're about the same distance from the center of gravity, or you can have one, and you want that pretty much at the center of gravity to keep it from slip sliding away. But we want to make sure we get the right one, so we're going to select from the database. We're going to get the Estes 1/8 inch lug, and there we go. And then we're going to, and there's this typical length. We're going to leave it the full length. And it was positioned in the middle, and we're going to move this down, and we're going to put it right about there. So you know, there's your center of gravity. It's on the center of gravity. Okay. Doesn't have to be exactly in the middle. Just around it. It's fine. And I only did that because I didn't want it to poke out from these fins. Okay. So we hit close. Now I wanted to show you something. We'll look at the back view of this. Go to the back view. And you notice it's right on the fin. Well, that's not what you want. So we're going to hit the launch slug again, and we're going to edit, and we're going to rotate it. See, rotate radial position, and we're going to go, let's see, we'll do, I did the minus direction because it does it this way. I'm going to keep doing it till it just clicks right there on the outside of the fin. So it's going to go against the body tube in the fin for maximum grip. Okay. And close it. And back to the side view. Alright, so we're almost, you notice here where stability is still 0.7, we're doing good. So we're going to add a parachute. And parachute is going to be a preset. So from the database, we're doing Estes. We're going to do an Estes 12-inch. Okay. The only thing we don't like about it, see how big it is compared. The only thing you're really concerned about here is how much it weighs and how far away from the center of gravity it is. So what it looks like is not really all that important. So we're going to, when you wrap this thing up, it's around 2 inches. And we'll keep it this around 0.7 so it'll fit in the tube. And then we'll slide it down because this is the shoulder, so we obviously don't want it there. So we're going to do, here we go, this, we're going to do, we'll do here, okay? And it doesn't have to be that far, but, well, we'll do here, okay. Then we'll put, fine. And then we'll add to this thing, we'll also add a shock cord. Okay, and the presets on this because it's just plain material. This electric crack. Typically, you want your shock cords to be at least twice the length of your rocket. So we're going to make this a 12, 24. Make it about 26 inches. Make this about 26. There's a lot of people. Some people like one to the length of the rocket. Some people do 2. Some people do up to 5. I think 5 is a little overkill, but if you have a high power rocket, it might be reasonable. Okay, and we're going to use the standard elastic cord, round elastic cord. And again, we don't want it's not going to be on the shoulder, so we're going to add some distance to it. That's reasonable. Right there, and we close it. And you see, now we're at 1.14. So we're more than the. And I don't like the looks of that because it doesn't fit in the shock cord. So we're going to do this. Shock cord, we're going to change this. The length is going to be like 0.5 because it's not even that. And the diameter is like, we'll do 0.7. Okay. Okay. Now you notice it did change it a little bit because position was important. Okay, so we pretty much have got everything here. All we got now is, all right, let's save it. Save. You can test it, save it, whatever you want. I'm going to save it as a test 1. Orc is a file type for OpenRocket. And I already have one, so I'm going to overwrite it. And there you go. There's your basic rocket. Okay. The only thing I want to show you here is when you get ready to do it, because you know you're stable, you can do a print or export. And what you can get is it only really prints from a PDF. So you can save it directly to a PDF and be done with it. Or you can preview it and print it, which basically creates the PDF and brings up your viewer so you can see it. Now, when it did that, it brought up everything. You can choose not to have all this in there, but by default it will. So there's a picture of your rocket. There's all the parts you selected. There's your wraparound for your BT-20 engine, BT-20 fuselage, so where you can set your fins on it and where you would set your launch lug. There's your fin template. You just cut that out and put that on a piece of flat balsa stock and you can cut it out. And there's your nose cone shape. The reason why they do that is some people create their own nose cones. So that's what gives them a shape. That's about it. So that's pretty much all it is on the first tutorial, how to, the very basics of getting OpenRocket to work. Yes, there are a lot more complicated things you can do, but at this point, we're just going to start with just this as a basic rocket. Please let me know if you anything else in particular you're looking for. I'll try to get it in the next set of tutorials. But right now, that looks like that's all there is to do. So, bye-bye for now.